Hello and welcome back. At this video, we will analyze the IPv4 and IPv6 packets, and we will get some samples from the Wireshark. And for each of those protocols, we will analyze the headers of the packets. And for the samples of IPv4 in the Wireshark, we will analyze the Ethernet packet. For the IPv4, the control information, and we will see the difference between packets because we will analyze 3 different packets from the Wireshark. So let's analyze the screenshot from Wireshark. And we have here the packet number 2 that is highlighted, which means that we will analyze this packet. And here are the layers. We have the physical layer, data link layer, internet layer, and the transport layer. And as you can see at the internet layer, we have the version, the source IP address, which is the same as this IP address, and the destination IP address, which is the same as this one. And we are interested to analyze the layer 3. And so we will expand the field of the packet header, and we will check all the information that is listed here. And at the version field, there is number 4, which means that this is a packet of version 4. It is IPv4 opposed to IPv6. We have the header length that is 20 bytes, and it is the shortest header. And we have the different service field, which stand for the prioritization of the packet, and it is used as the application voice over IP. We have the total length of the packet, and we have even the identification field, and this field it is used for fragmentation of the frame. And we have the flags for the fragment, which stand for don't fragment, which means that this is a small packet, so don't need to be fragmented when it travels across the network. The fragment offset is 0. And we also have the time to leave as 128. The time to leave, it is decreased every time that the packet cross or go to a router. And when the time to leave is 0, it means that this packet needs to be dropped. And we have even the field of the protocol, which is the number 6, which stands for the protocol TCP and identifies the protocol that is being encapsulated from the upper layer. We have even the header checksum, and the header checksum stand for correct, which means that this is a correct packet. It is not damaged. And the 2 fields that are very important is the source field of the IP address and the destination field of IP address. As you can see, this information is the same as it is listed here in the packet. And the other layer is the transport control protocol, which is not in our interest for the moment. Now let's go and see the packet number 8 and to see if there are any similarities or differences with the packet number 2. And as you can see, the source and the destination IP are the same, but it is an HTTP packet, which means it's a GET request for the server at 192.168.1.1. And if we expand the Internet Protocol layer, we will see that some fields are the same as version, header length, the protocol, time to leave, source, and the destination. But what has changed is the total length of the packet, which stands for 411, and it means that this packet is larger than the first one. And if you go through the layers, you see that after the transport layer, we have even the hypertext transfer protocol as it is listed here. And it stands for the upper layer. And if we go and analyze the packet 16, we see that this packet is from the same source host and the same destination host, but it is an ICMP packet, we stand for echo or as a ping request packet. And if we expand the layer of the 3, we will see that the Internet Protocol header, it's with some differences, but the version and the header field are the same. The total length is less than the second packet, and we see that the flags are different, and the field of the protocol for the upper layer is different. It is set as 1, and it stands for Internet Control Message Protocol, which is a message packet. And at the upper layer, there is the information about the Internet Control Message Protocol that you can expand and see what's more. And as we go to the samples of IPv6 in Wireshark, we will analyze the same as for the IPv4. We will analyze the IPv6 Ethernet packets in Wireshark. We will see the control information for each of them, and we will see the differences between packets as at the first examples with the IPv4. So let's go and analyze the IPv6 packet now at Wireshark, and we will analyze the packet number 46. And in this packet, we see that this is the source of global unicast address, and even for the destination is a global unicast address. We can understand that for the first two sections, we stand for 2001 and 6F8, and both of them. And if we go to the upper layer, we see that is a TCP protocol, and it stands for an established connection with an HTTP web server. And if we expand the Internet Protocol layer, we see that we have the version 6, which stands that this packet is an IPv6 packet, and we have even the binary format, and we have the traffic class here, which is the same as a differential service at the IPv4 field, and it is for the prioritization of the packet. And we also have a feature that is added here. We have the flow label, which stands for the packet with the same flow to be processed the same way by the router and layer 3 switches. And we have even the payload length, which is the same as total length at the IPv4, and it shows that the length of this packet is 40. And the next header is to show how the protocol of the upper layer, which is the number 6, and stand for the TCP protocol as it is listed here. And we have even the hop limit, which is 64, and the hop limit is the same as time to leave for the packet at the IPv4. And we see that there isn't any checksum, and we have the source and the destination of the IP address. And we have the transmission control protocol for the upper layer. And as you can see, the header of the IPv6 is shorter and smaller than the header of the IPv4. And if we go and analyze the packet 49, we see that they are from the same source and the destination, but it is a GET request for the server. And if we expand the layer of Internet Protocol, there are some difference from the first packet, and the differences is at the payload length, which means that this is a larger packet with more information. And in this screenshot, it is not listed, but we have even the layer of hypertext transfer protocol under the layer of transmission control protocol. And as we analyze the last screenshot from Wireshark, we will analyze the packet number 1. And as you can see, this packet is from a linked local address from the source, and we can see from the first socket FET0, and with a destination as a multicast destination, and it's for the neighbor solicitation. And if we expand the Internet Protocol layer at the header, we see that the version is still 6. We have the traffic class, a flow label. We see that the payload length is 32 now, and the next header, which stands for the protocol at the upper layer, it is as 58, which is an IPv6, which is an Internet Control Message Protocol version 6. And this packet, it has like an RP request, which means that we need to discover the IP address of the neighbor, of the destination. And we also have the layer of the Internet Control Message Protocol that if we expand it, we will have more information. But for the moment, we are interested in this layer and the header of these layers. So with the samples from Wireshark, we were able to understand and compare the IPv4 protocol and IPv6 protocol. But even for each protocol, we were able to see the similarities and differences at the header for each different packet. Thank you for being with me. See you to the next session. And please, for those who are new at this channel, do not forget to subscribe at this channel and hit the notification button for new videos that will be uploaded.